Okay, I'm going to cover the assembler. So you can, there are three assembler situations. You can have an assembly block inside of a C function. You can have an assembly block outside of a C function, or you can even have just instructions. It's smart enough that when an opcode starts a statement, it knows it's a assembly instruction. So you'll frequently see in the operating system code, you'll frequently see I equals 0, I less than 1. No, let's just do that. F5. No, let's see. Okay, so let's unassemble that. Unassemble function main. So there's the push flags, clear interrupts, that turns them off, set up the for loop, do the for loop, pop the flags. So if you know what the stack is doing, you can mess with it, but you have to know what you're doing. That's dangerous, but if you're I do it all the time. Anyway, so if you have an assembly block by itself, this is, let's say, define. In other assemblers, you say define byte. Well, in this operating system, it's define U8, and then we have a string, but it's not zero terminated. You have to zero terminate it. So now we define. Now I have a convention. This is not mandatory, although I don't have to tell you that. I might as well just say it's mandatory. You put an underscore if it's C callable. So I normally follow the standard, the old-fashioned stack frame. So now let's go ahead and call put move RSI. So we have to preserve RSI. I can tell you which registers you have to preserve. So in between C instructions, you can clobber AX, CX, DX. Basically, you can always clobber these, except not RBP and RSP. A, B, C, and D you can clobber. 8 and 9 you can clobber. But you have to preserve RSI, RDI, 10, 11, 13, 14, 15, 12, 13. And you have to preserve RBP, RSP. So we have to preserve our RSI. I don't know where we want to put it. We can put it here. Well, that was almost catastrophic. My video dies if I crash, so that would have been bad. Okay, so we have a function. This is in assembly you basically have labels, and they're in. When you mix them with C, they look like just numbers. Calls a number. So I just did hello world, and it worked. You might want a new line, a couple new lines. Now we do it again. We got that. We can put a couple new lines in the beginning. Okay, so to unassemble, you can say unassemble my function. This is just a number. So what do we have here? We have, there's the function. It's got put string. Now, you might find a situation where you have to say import, like for example, put chars. We're going to do an alternative. Okay, so 1 colon is not exported. 2 colons is exported. It's an exported symbol. Okay. Okay, we're going to call put chars. Let's call the this is a C function. So we're going to pass one parameter. So we're going to move. Let's go ahead and put it in RAX. Now we put how about that? And we say push RAX. Now these the standard is to use the pop return. Okay, now let's go ahead and do this, and then we'll explain it. Okay. Okay, so it printed hello question mark. I'm a little bit nervous. If I crash, I'm dead. Anyway, okay, so so if we don't have this, I better not do that. It might crash. The alternative is to put an ampersand. That also works. The safest is to do an import. So you say import put chars, and you put a semicolon. You do a comma list and then a semicolon, and then you're free to use it. So if you have you can use local labels. Add @1. You can even renumber. Watch this. Control Shift L. Oh, let's go ahead and let's loop add @1. How about if you're move RCX 5? We have to preserve it. It'll get clobbered. Oh, I have to. No, I almost screwed that up, didn't I? Paying attention. Okay. Pop RCX. Okay. So watch this. Control Shift L. Renumber assembly local labels for function. Now it just changed it to 5. It goes by 5s. 5, 10, 15, 20. So every time you have a double colon, that makes a new section, and then you can add repeated local labels. Okay, so double colon is an export, and it's a new section. Single is not exported, and it's not a new section. Okay, add at is a local label. So let's go ahead and now there's a more sophisticated way. That was raw. These labels are like raw numbers. You can bind them with an extern. Extern underscore extern will bind an assembly label with a with the C function header. So this has no args. And then we can use, we can say function 1. Oh, my function 1. I'm very nervous. I already lost a video because I crashed it. Okay, so this is more normal. Okay, so there's one more thing. We want to cover class. My struct. Okay, so if we have a class U8 name 32 U8 address 32, to do that, what do we want to do? Let's just go ahead and move RAX, comma, my struct, let's just do that. Oh, no, let's, my struct dot address, and then we say call put hex U64. This is RAX. It preserves registers. I have a handful of assembly useful functions. There's a few assembly callable functions. Not very many. This, we're going to print out RAX, and let's go ahead and move RAX, comma, carriage return, call put chars. So I do believe, is this going to work? We're going to print the offset number and then print a carriage return. I hope I don't crash it. Okay, we printed 20. That's hexadecimal for 20. Okay, now we're going to go ahead and we're going to do a parameter. How about count? I64 count. Okay, now move RCX count. Okay, now there's some. These are very important. SF stack frame arg123. Stack frame arg123 FRBP. Okay, so now I say push RCX pop RCX loop add at 1. I hope I don't crash anything. Oh, I almost crashed it. Holy. Okay. Okay. Function 1. Okay, we printed the number twice. This is a stupid program. I'm sorry for a stupid example. Okay, so let me explain. This is an opcode, a funny opcode. Go to the compiler directory in the opcodes file, and there you will find all my opcodes. I didn't enter all the opcodes. There's no MMX, no SSE. Let's look for return 1. Okay, so there's a return, and then there's a return 1 that has a count. Excuse me, this is not for me. Anyway, so let me explain why I did this. If you look at mul, there's a 2 argument integer multiply, and there's a 1 argument integer multiply. The reason I de-ambiguous I make it de-ambiguous is because I use the same compiler Lex. The lexical analyzer breaks these up into pieces, and it's the same as the C. So this is just like C code. This is exactly the same lexical analyzer as C. So it doesn't recognize, there's nothing special about a carriage return, just like a C program. So what I had to do is I had a problem. If I just said return 8 like this, then I wouldn't know that there was an argument. So I have to say return 1, 8. This is a little known, this pops the stack. This pops 8 off the stack. That's to get rid of the parameter that was pushed. And this is the convention that my functions use, except variable parameter count doesn't use that. Anyway, so I think I covered everything. Now there's a $sign. If you want, you can say $sign equals 10. That's a 10, not a 16. Okay, now let's see what we have. 2A. Okay, so $sign. I think, how do you align? Oh, I guess you have to do it this way. Equals $sign ampersand minus or tilde 7. So this is how you align. 28. So 10 plus 32 is 2A. Oh, then you don't want that. Anyway, you just do the math. 30. So there's a sometimes I put a pad, U0 pad. Now what that is when it's lexing, unfortunately it's a symbol ahead. So if I say assert $sign ampersand 7, not $sign ampersand 7, this is to make sure it's aligned. If I do this, my assert, by the way, is a pre-compiler that prints a message if it's false. That's how we learned it in my class. It's not a runtime assert. Not a runtime assert. Anyway, I think what I do is I do a pad because it's lagging a symbol. This is really ugly, but my compiler in this particular case lags a symbol. In other words, it hasn't gotten caught up at this point, so you have to do a no-op. That's what this is. Anyway, you'll see that in the header. Anyway, let's see if we have any other. I might as well tell you about. Okay, I might as well tell you about DU8 DUP. You say 10 DUP. I guess we can put anything. How about A? Let's see what that does. And then we put exported my data. And then we put a dump. That's just a symbol. Let's go ahead and get rid of all this. Dump my data. So we have 41, we have a bunch of A's. And how about DU16? Let's do CD. Let's see what happens. Okay, so A, CD, CD, CD. Okay, so you get the idea. Let's see if I covered all the assembler directives. I think it's in directives. Uh-oh. Holy C, where did I? Uh-oh, I'm sorry, guidelines. No, we want, let's say find direct. I'm just going to do this quickly. Find directory. Okay, compiler overview. Well, that's pretty. Okay, include a $.dxe and doesn't executes code at compile time. Let's see, here's the assembler. So I told you about the $. Label defines an export global. It's also a new section. It also marks a new section. Finds a non-exported. Add-at's a local. DU8, okay, I forgot use. There's import. List is kind of broken. Oh, you can align, not in a structure, by the way. That's only limited. You can't really align. Oh, by the way, you do not have the right to tell where the code goes. That is not your option. You do not have the right to tell where the code goes. I made an exception. Let's see. Module org. I don't even know how this works. Let's see. 0x. I'm going to put it just in some safe memory that I know exists. DU8. 0x. Oh. Let's see what this does. Module org. Okay. Now let's dump 0x. This is just some crazy apps. Okay, so it did work. Okay, so you can specify where it goes, but you really shouldn't be doing that. Okay.